Within the folds of modern science appears perhaps the greatest untold story of our generation. It is the simple but seismic truth that the psyche is capable of gleaning information beyond the five senses and all known technology. In plainest terms, this capacity is called extrasensory perception, or ESP. Decades of replicated and bulletproof findings validate this rejected fact of human nature. We are beings both material and immaterial, physically limited and elevated by laws and forces we've only begun to codify. Join me, Mitch Horowitz, as I explore the history, struggles, and proofs of parapsychology, uncovering the extraordinary evidence that ESP is real. Episode 6, Pink Buckets, Act 2. Ultimately, I believe it falls to each generational cohort to venture a theory of phenomena in which it professes deep interest. That theory can ignite debate. It can be thrown out and replaced. It can be modified. But I do not believe that researchers and motivated lay inquirers like me can eschew the task. To begin, I ask, is it really so strange, so violative of our current body of knowledge, that there exist quantifiable exceptions to ordinary sensory experience? Most of the founders of quantum theory were philosophical idealists. That is, they interpreted and documented a naturalistic universe that includes and is affected by laws of perception. This demonstrates that world-class science that created the modern world, was actually performed on an entirely different set of worldview assumptions, Dean Radin remarked to me on December 31st, 2021. The father of quantum physics, Max Planck, observed, "All matter originates and exists only by virtue of a force which brings the particle of an atom to vibration and holds this most minute solar system of the atom together. We must assume behind this force the existence of a conscious and intelligent mind. This mind is the matrix of all matter." And elsewhere, I regard matter as derived from consciousness. A new era in perceptual studies arrived when theoretical physicists began discussing the many worlds theory devised in 1957 by physicist Hugh Everett III. Everett was attempting to make sense of the extraordinary findings that had been occurring for about 3 decades in quantum mechanics. For example, scientists are able to demonstrate through various interference patterns that a subatomic particle occupies a wave state, or state of superposition, that is, an infinite number of places, until a sentient observer or automatized device takes a measurement. It is only when measurement is taken that the particle collapses, so to speak, from a wave state into a localized state. At that point, it occupies a definite, identifiable, measurable place. Before measurement is taken, however, the localized particle exists only in potential. I am using language that sometimes raises objections. A critic wrote me, "The wave state you describe is a wave function, which is descriptive of the particle's energy. That wave function, when squared mathematically, gives you a probability of its spatial distribution. So the wave function is a square root of a probability distribution." Yes and no. As my colleague Dean points out, the wave function is not about probabilities. It's much stranger than that. It's the square root of probability, which some distinguish from probability by calling what the wave function represents a possibility. In any case, the wave function describes a state as much as a formula. Now, I have just about squeezed all of quantum physics into the size of a marble. I consider it an accurate description, but obviously I am reducing huge complexities. I believe I am faithfully stating what has been observed in the last 90-plus years of particle experiments, as well as emerging experiments on larger objects, such as hydrogen molecules. We are seeing that on the subatomic scale, matter and cognition or perception do not behave as we are conditioned to expect.
One of the consequences of modern physics is that as I think Sir James Jeans said, that the world begins to look more like a giant thought than a giant machine. What he meant is that down deep in the quantum view of the world, the thing that is most important is information and knowledge. That seems to be the driver of everything. And in addition, the more you look at individual particles, the more you realize that there is no such thing as one electron. An electron, or any elementary particle, exists only in relationship to other things, like other particles or the universe at large. This means that deeply enough, and you dive down into the nature of matter, everything we know about the everyday world dissolves. There are no objects anymore. There are only relationships. There's no locality anymore. There's no time anymore. It all begins to dissolve away. That's why I use this idea of like the Cheshire cat dissolves away and all that's left is a smile, and eventually that goes away too. The more you look at something in detail in what we think of as solid matter, the less and less solid it begins to look.
Starting about 20 years ago, it became fashionable for New Agers and lay people, like me, to place quantum theory at the back of cherished metaphysical principles. It became equally fashionable for professional skeptics and mainstream journalists to push back, crying BS and sophistry. That position, while still heard, has quieted, not because skeptics have grown more pensive or attenuated to media speak, but because the proposition of mind liberated from matter, strange as it may seem, now resounds in debates on theoretical physics in mainline journals and magazines. Our understanding of matter and experience in our macro world generally comes from measuring things through our five senses and experiencing them as singularities. There is one table. It is solid and definable. It is not occupying an infinite number of spaces. It exists in a particular moment in time. But contemporary quantum physicists have theorized that we may not normally see or experience superposition phenomena because of what is sometimes called information leakage. This means we gain or lose data based on fineness of measurement. When you measure things with exquisitely well-tuned instruments, like a microscope, you see more and more of what is going on, that is, actual reality. But when you pan the camera back, so to speak, your measurements coarsen and you see less and less of what is actually happening. Again, to use the most basic example, to all ordinary experiences, a table is solid, the floor beneath your feet is solid. But measuring through atomic scale microscopes, we realize that if you go deeper and deeper, space appears within these objects. Particles make up the atom, and still greater space appears. We do not experience that. We experience solidity. But no one questions that space prevails among particles composing an atom. Furthermore, we possess decades of data demonstrating that when subatomic particles are directed at a target system, such as a double slit, they appear in infinite places at once until a measurement is made. Only then does locality exist. But we fail to see this unless we are measuring things with comparative exactitude. Hence, what I am describing seems unreal based on lived experience, but it is actual. In any event, my supposition is this. If particles appear in an infinite number of places at once until a measurement is taken, and if, as we know from studying the behavior and mechanics of subatomic particles, there exists an infinitude of possibilities, and if we know, as we have since the inception of Einstein's theories, that time is relative, then it is possible to reason, and it is almost necessary to reason, that linearity itself, by which we organize our lives, is illusory. Linearity is a useful and necessary device for five sensory beings to get through life, but it does not stand up objectively. Linearity is conceptual, a subjective interpretation of what is really going on. It is not reflected in Einstein's theory of relativity, which demonstrates that time slows for an object approaching the speed of light. The individual traveling in a metaphorical spaceship at or near light speed experiences time slowing, not from their perspective, but in comparison to those not at near light speed. And this is no mere thought exercise. Space travelers in our own era, although they are obviously approaching nowhere near that velocity, experience minute but measurable slowing of the aging process. Nor is linearity reflected in quantum mechanics, where particles appear in an infinitude of places and obey no orderly modality. Linearity is not replicated when measurement of a particle serves to localize the appearance or existence of the object. This begins to clarify why Einstein famously remarked in a letter of March 1955, "People like us who believe in physics know that the distinction between past, present, and future is only a stubbornly persistent illusion." If we pursue this line of thought further, and this is where Everett's many worlds interpretation comes into play, the very decision to take a measurement or not take one not only localizes a particle, but creates a past, present, and future for that particle. Hence, an observer's decision to log a measurement, or even an automatized device doing so, creates a multidimensional reality for the particle. Multidimensional reality is implied in the famous thought experiment called Schrödinger's cat. I once saw a cartoon in which a household dog was whispering into the ear of a napping Schrödinger, "Psst, Erwin, old buddy, choose the cat, choose the cat." We'll get to what the dog meant in just a moment. 20th century physicist Erwin Schrödinger grew frustrated with the evident absurdity of quantum theory, which showed objects simultaneously appearing in more than one place at a time. Such an outlook, he felt, violated all commonly observed physical laws. In 1935, Schrödinger sought to highlight this predicament through a purposely absurdist thought experiment, which he intended to force quantum physicists to follow their data to its ultimate degree. Schrödinger reasoned that quantum data dictates that a sentient being, such as a cat, can be simultaneously alive and dead. Here is a variant of the Schrödinger's cat experiment. A cat is placed into one of a pair of boxes. Along with the cat is a collar fitted with a device which, if exposed to an atom, releases a deadly poison. An observer then fires an atom at the boxes. The observer subsequently uses some form of measurement to check on which box the atom is in. the empty one or the one with the cat and the poisoning device. When the observer goes to check, the wave function of the atom, the state in which it exists in both boxes, collapses into a particle function, the state in which it is localized to one box. Once the observer takes his measurement, convention says that the cat will be discovered to be dead or alive. But Schrödinger reasoned that quantum physics describes an outcome in which the cat is both dead and alive. This is because the atom, in its wave function, was at one time in either box, and either outcome is real. Of course, all lived experience tells us that if the atom went into the empty box, the cat is alive. And if it went into the box with the cat and the poisoning device, the cat is dead. But Schrödinger, aiming to highlight the frustrations of quantum theory, argued that if the observations of quantum mechanics experiments are right, you would have to allow for each outcome. To take it even further, many worlds theorists in the 1950s posited that if an observer waited some significant length of time, say 8 hours, before checking on the dead-alive cat, he would discover one cat that was dead for 8 hours and another that was alive for 8 hours and now hungry. A divergent set of outcomes would exist if that measurement were never taken. A divergent set of outcomes would also exist if that measurement were taken 1 second later, or 5 minutes later, or tomorrow. And what is tomorrow? When particles exist in superposition until somebody takes a measurement, there is no such thing as tomorrow, other than subjectively. Consider, too, the cat, from its perspective, is local. The observer, from its perspective, is local, but both, in fact, are in a wave state or superposition. We can speak of them as concrete, singular beings only from their personal perspective. From the quantum perspective, they are infinite. Expanding on this idea, research physician Robert Lanza, adjunct professor at Wake Forest University School of Medicine, argues that death itself is ultimately a mental phenomenon. We die only insofar as an observer perceives demise. The consciousness of the deceased branches off into one of Everett's many worlds. This begs the question of who experiences these effects if there's no such thing as one person/life.
Well, that means that observation determined existence. So you're now left with a very horrible, absolutely incredible paradox. Either the act of observation determines the existence of a cat, or the cat is simultaneously dead and alive. Both alternatives are mind-blowing. Both alternatives shake philosophy to the very core. Let's take the first alternative. Observation determines existence. But observation requires consciousness. Therefore, consciousness makes an observation, and then we see the cat is alive. Well, I determine the fact the cat is alive. Well, who determines me?
Stay tuned in for even more extraordinary evidence after the break. The perceptual basis of reality has an adjunct and an adjunct set of possibilities in what is called string theory. String theorists attempt to explain the strange behavior of subatomic objects, as well as why such objects affect one another at distances, and why, as Isaac Newton observed, even macro objects at vast removes mirror each other's motions. String theory holds that all particles and all matter are not separate entities, but rather exist along vast, undulating networks of strings. When an object at one point in space affects another object, we are not seeing two distinct entities, but a unified string of objects. What's more, different dimensions and universes exist along these strings, so we may not always see the thing causing an effect. I am deferring to the language of causation, a typical Western formulation. Another vista opens if one argues for correlation. In string theory, all matter and events are of one whole. We catch only hints of this through exquisitely fine measurement. And what, finally, are our five senses but a technology by which we measure things? Are our five senses anything other than a biological technology, not necessarily different in intake from a camera, photometer, digital recorder, or microscope? So, it is possible that within reality, within this extra-linear, superpositioned infinitude of possibilities in which we are taking measurements, we experience things, including seemingly discordant and out-of-reach information based on perspective and measurement. William James, in his Gifford Lectures in 1902, made an observation that speaks to this. When a mystic sees something, James said, it is as if he is viewing it through a microscope. The mystic sees more and more of what is really going on because of his extreme sensitivity. If I look at a drop of water, all I see is a common drop. It is translucent. It feels like what I call wet. But if I look at that same drop through a microscope, all kinds of things are revealed. There are single-cell organisms. There are bacteria. There are molecules moving around. The molecules are made up of atoms and other particles that are similarly moving around. All kinds of things are occurring that I do not normally see. James contended that the mystic is always viewing things as though through a microscope. But again, when you pan the camera back, so to speak, you experience less and less of what is really happening. Without crediting James, this is what some quantum physicists today call information leakage, as noted earlier. They respond to the apparent disparity between the particle world and our macro world by saying what James said about mysticism, which is that when you are measuring things with extremely fine and well-tuned instruments, including, I argue, the psyche and senses, you are seeing more and more of what is really going on. But when your capacity for measurement coarsens, you lose data and see less and less of what is occurring. This can account for visionary experiences from St. Teresa of Avila to Philip K. Dick. Evidence aside, critics often say that ESP and related concepts clash with widely established physical laws. In a 1960 essay, theoretical physicist Eugene Wigner spoke to the commonality, if not inevitability, of natural laws that do not necessarily square with one another. Every empirical law has the disquieting quality that one does not know its limitations. Alternatively, it is possible that there will always be some laws of nature which have nothing in common with each other. It is even possible that some of the laws of nature will be in conflict with each other in their implications, but each convincing enough in its own domain so that we may not be willing to abandon any of them. And further, it may be useful to illustrate the alternatives by an example. We now have, in physics, two theories of great power and interest: the theory of quantum phenomena and the theory of relativity. These two theories have their roots in mutually exclusive groups of phenomena. Relativity theory applies to macroscopic bodies, such as stars. The event of coincidence, that is, in ultimate analysis of collision, is the primitive event in the theory of relativity and defines a point in space-time, or at least would define a point if the colliding particles were infinitely small. Quantum theory has its roots in the microscopic world, and from its point of view, the event of coincidence or of collision, even if it takes place between particles of no spatial extent, is not primitive and not at all sharply isolated in space-time. The two theories operate with different mathematical concepts. So far, the two theories could not be united. That is, no mathematical formulation exists to which both of these theories are approximations. All physicists believe that a union of the two theories is inherently possible and that we shall find it. Nevertheless, it is possible also to imagine that no union of the two theories can be found. This example illustrates the two possibilities of union and of conflict mentioned before, both of which are conceivable. Hence, it is no argument against anomalous or paranormal events or reports of such to maintain that they violate natural laws. It could be said that we violate our own laws all the time, rarely fretting over implications. As H.P. Lovecraft put it in the opening line of his famed 1926 short story, The Call of Cthulhu, "The most merciful thing in the world, I think, is the inability of the human mind to correlate all its contents." Under what circumstances might an individual experience such a violation? To recap, just as linear time is a device, just as particles exist in a wave state or state of superposition, it is possible that we live amidst an infinitude of events, including those we call anomalous, which we perceive only in fragments or at fleeting moments. Maybe the experience of extraordinary events, those that violate common observation and presumed lawful consistency, including ESP, occur at moments of great awareness, sensitivity, or emotional investment, or perhaps at moments when ordinary thought patterns, for whatever reason, get interrupted, or possibly there exist moments available to some individuals with aptitude for ESP or intuition. It could be that at such times, the individual is capable of seeing what is really happening. Yet, such individuals are sometimes smeared with terms like psychosis, crackpot, fraud, imagination, fantasy, or confirmation bias. Materialists over-rely on confirmation bias, a clinical term for prejudice, and related concepts to disregard testimony, which they dismissively call anecdote. Consistent testimony from varying sources forms a record and warrants consideration. Strident materialists, of course, fail to grasp that cognitive biases and prejudicial thinking are their own problems too. None of what I've explored suggests that those labels, judiciously applied, are always wrong. Just that they're not always right.
We don't feel that this contradicts modern physics, and it certainly doesn't make modern physics wrong, because modern physics is an enormously successful body of knowledge. What it says is that modern physics is incomplete in many ways and is presently inadequate to describe the data that we've accumulated over this past 10 years' research.
More extraordinary evidence when we return. If my hypothesis is correct, which is to say, in homiletic terms, you get what you're looking for, we're all in the same boat. Or, as Robert Anton Wilson put it, all perception is a gamble. Let us consider matters in an interdisciplinary way and try to determine the topography. We will not get anywhere, or at least not very quickly, if we dismiss, underfund, or effectively ban the so-called borderline sciences. In sum, I posit that an individual, either because he or she is uniquely sensitive at a given moment or experiences a reduction of sensory data while retaining awareness, as in the Gonsfeld experiments, may be capable of accessing information or taking sensory measurement of other states or dimensions that exist along the conceptualized bands of string theory. This may hold true for dream states as well. We call these measurements precognition, telepathy, ESP, or psychokinesis, the last of which may be a form of pre-awareness or movement or both. But perhaps that is simply what finer measurement looks like. It is possible that measurement, and what else is sensory data, not only informs, but also, at least in certain cases, crosses intersections of space-time. A law, in order to be such, must be consistent. If there exists a law of extrasensory perception, that law may be constant, but also experienced unevenly based on surrounding circumstances, as with other natural laws. Gravity, for example, is affected by mass. We may get distracted, overloaded, fatigued, and attenuated to experiencing reality. This may be our general state. ESP is bound up with other factors. And so, ESP, whatever it may be, J.B. Rhine wrote in New Frontiers of the Mind, is, at any rate, a part of the general complex process system that we call the mind, or, to be still more inclusive, of the personality as a whole. Perhaps if we gleaned more of what is actually going on, or exercised fuller capacities of sensation, the experience would prove overwhelming. We would be overcome with data. Hence, we may require a linear sense of time and a limited field of information in order to navigate experience. I believe we may be approaching a new understanding of anomalies, including UFOs, near-death experiences, apparitions, and the discordant and nonlinear data of ESP, precognition, and retrocausality. It is possible that all of this testimony, replicable data, and experience could point to something of a non-materialist or extraphysical quality pertaining to interdimensionality and different intersections of time and the psyche's ability to traverse them. Cognitive psychologist Steven Pinker, responding to my 2022 lecture, Case Closed, ESP is Real, wrote, "It's also true that many phenomena in physics challenge common sense, so our intuitions about what is physically possible can't be taken at face value to set a Bayesian prior on ESP. But that doesn't mean we can point to some counterintuitive physical phenomenon from quantum mechanics or relativity and conclude that any weird thing is possible. This is what Horowitz did at the end of his talk when he invoked time dilation near the speed of light in special relativity to explain how a student might effectively study for an exam after it's over. To call this physics for poets would be a disservice to poets." But would it? As we validate these seeming exceptions, trace their arc and occurrence, and replicate the conditions under which they appear, Perhaps we approach what William Blake foresaw in 1790 in The Marriage of Heaven and Hell. If the doors of perception were cleansed, everything would appear to man as it is, infinite, and thus ineffable. Raising this question, and evidence supporting the validity of its asking, are the legacy of J.B. Rhine and the parapsychologists. I say, carry it forward. Or, in a different manner of words, know thyself. To do otherwise would mean accepting estrangement from our true nature. And might such estrangement be at the root of the anxiety and ennui that characterize so much of life in the contemporary West? By contrast, validly expanded codification of human abilities could open new vistas in understanding the nature of our being in a manner akin to the impact of Darwin's theories on the Victorian mind. The extraordinary evidence is already ours. It seems inconceivable not to try.
Dr. Ryan, if ESP really exists, what are its implications?
Well, it does really exist. It does really occur, we'd say. The implications begin with the basic fact that ESP is non-physical. It shows that there's something that man can do that extends beyond space-time. That's tremendous. That's like discovering another continent, a new world. First, take religion. Most of the world is religious. What is the greatest enemy to religion, or the greatest weakness in the position of religion? The fact that it cannot successfully refute the growing conception in the world of science that man is a wholly physical being. That is, it's the position of materialism. If religion could refute materialism, it would be in a much firmer, sounder position, because it stands on the assumption that there's something spiritual or extra-physical about man. Parapsychology establishes that in this experimental evidence of ESP and other abilities.
Thank you for listening to Extraordinary Evidence, ESP is Real. This series was produced by Jim Perry and John McEdward for Spectre Vision Radio, edited by John McEdward, with original music by Dean Hurley, written and narrated by me, Mitch Horowitz.